In my presentation, I mentioned that for the methods, I'm using web page tool to make origin input. We will see the web page tool that I'm using to make origin input. This is the visualization of the tool, the software. I'm using PHP computer program language to make this input. Origin input maker for aqueous homogeneous reactor. We have to insert the data right here. The first is reactor operation time in days. For example, I'm using 3 days. And then the reactor shutdown time in days. For my thesis, I'm using 2 days as the reactor shutdown time. The shutdown time is the period that needed to extract the molybdenum 99 as the result of the product of this reactor. And then the reactor power in megawatt thermal, 0.2 megawatt or 200 kilowatt thermal. And then I have to choose one of these options, 1 and 2. One is for fresh fuel and the second is non-fresh fuel. I have to upload .pch file because this is the first cycle, so I am choosing this one. The fuel is uranyl nitrate solution. Choose this option only for fresh fuel or the first cycle, and then I submit, and then I can download the input file right here. We see the result in the download folder. We move it to origin folder. We see right here, this is the input of the origin. We will see this input. This is the input of the origin. The most important I mentioned is this is the first cycle, so the fuel is fresh uranyl nitrate solution. We'll see right here, this is the symbol of hydrogen. The atomic number is 1 and the atomic weight is 1, and this is the amount of hydrogen in mole. This is for oxygen. This is the amount for in mole. This is nitrogen, and this is its amount in mole. And this is uranium. Atomic number is 92, and then this is the atomic weight, uranium 235, and this is the amount of uranium 235 in mole. And this is the uranium 238, and this is the amount in mole. Okay, and then we will run the software origin, and we see right here, this is the result. We'll see the result as the material input. We see the same thing. This is the symbol of hydrogen. The atomic number is 1, atomic weight is 1, and this is the amount in the mole. For another nuclide, for example 92 for uranium, this is 92 atomic number. For uranium 235, we see right here, this is the uranium 235, and this is the amount of the uranium in mole. For the result of molybdenum, we will search it for molybdenum. 42 is the atomic number, and then 99 is the atomic weight. We see right here, this is the molybdenum, and this is the amount of molybdenum that we can extract in the unit of mole. Okay, and then we will rename this input as the cycle 1, and this is the output for the cycle 1, and we return to the tool for making the input. For the second cycle, the reactor operating time, shutdown time, and the power is the same, but the difference is the fuel. We are using non-fresh fuel, so we upload the .pch file. The input of the fuel is the output of the cycle 1. We submit, and we see right here I have made the software make it easy for me to extract the molybdenum. We see right here we get the result of the molybdenum and mole, and another we convert it to curie, and then right here we can download the input for the second cycle. We'll move this to origin folder, and this is the input for the cycle 2. We can see it. The difference with the cycle 1 is the material composition of the fuel is so many. This is line number 42 until line number 164, so it's about 120 row or line, and for every row we have 3 nuclei. So it means for the second cycle, in the core there is about 360 nuclei. And we will run for the second cycle. We see right here, this is the input of the cycle 2, and this is the output of the cycle 2. We'll see the output of the cycle 2. We see right here, this is just the same format. This is the nuclide identifier, and this is the amount in mole. For example, also we will search for uranium 235. Where is it? We can use it search option right here. This is the uranium 235 and the amount in mole. And also for molybdenum 42 atomic number, and then 99 for the atomic weight. This is the molybdenum in the output of second cycle. For the third cycle until the 10th cycle, we are doing the same thing, make the output of the cycle 2 as input and then submit it. We got the molybdenum, we get the input for the third cycle. Let's open the file, so I'm closing again. I move it the input for the third cycle in the origin folder. This is the input for the third cycle. We run it and we get the third cycle output, and it's continue until 4, 5 until 10 cycle.